Hello guys and welcome to this video. So in this video we're going to talk about a very important aspect of arrays and how arrays are actually created in the main memory and how we can assign one array into another. So we looked into this example before and to kind of illustrate the concept, I will just actually create this array in Java, and then we're going to talk about um, the important thing related to this video. So this is an integer array called A, and then I'm actually storing 1, 3, 8, 23, and 99. So now something related to what we already talked about, which is if we actually try, once we create this array, this A, the variable, for arrays, it's actually like a reference. So in memory, A is used to kind of locate all these different cells. So for example, when I define another array, which is an integer array called B, if I do something like B is equal to A, this is actually not like when you do something like int age is 5. This is actually called the primitive assignment, which is going to work in a way where the value of 5 is going to be copied into the variable age. For arrays, because A and B are both arrays, when you do something B equal A, what's going to happen in Java is that we will kind of like have another reference in addition to A that's actually going to be B in this case. So there's going to be another pointer, and this pointer that we will have is just going to be B in this case. So now the end result is that you will have both A and B that point exactly to the same place in memory. What this means that if you make a change to this array through A, if you try to access the array through B, B is going to actually see the change, and the change is going to be reflected as well. Because we're not here making two different copies, the same copy of the array exists in the main memory. So either if you change it through A or B, the content is just the same. And it's kind of like multiple ways to access the same data and work on the same data in the way you would want. So now when I do something like this, so now again, this is actually called, like you make an assignment on arrays, but essentially you're creating a new reference to the same array. So now, if I do something like A of 0 is equal to 200, if I try to do S out B of 0, actually, you're going to see also 200, because again, I changed it through A, and then I tried to access it through B, so this actually caused the change as well to be on the same array, giving us the 200. Similarly, I can actually do B of 1 to be something like 100, and then I try to do on S out here A of 1, and you will see exactly the same value. We pretty much have 100 here as well. So now either you make the change through the original reference variable A, or whether you make the change on the new one, it's not going to be any different, because this is actually something called access by reference, not by value. So the reference is kind of like the key, and you might have for the same door multiple keys, and as long as you can open the door, it's exactly the same concept over here. So you can access this whether through A or B, or even if you add kind of new references to the same array, it's just going to work in the same way. Now this concept also applies to methods. So let's look into an example. If I try to do public static void change AR for array, we take an integer array, and let's say we do for int I equals 0, I is less than arr.length, I plus plus. Imagine we multiply each element of the array ARR by 100. So that's going to be ARR of I. It's going to be ARR of I times 100. And let's actually call this method from the main on the array A. Now, what I will do now is I'm actually going to delete these because I don't really need them. So this is the array. I called this method on this array. Now watch when I actually try to print the content of this array from the main. See what happens. So we're just going to do s out a index I. And that's going to be a dot length. Okay, so let's see what happens. See, we actually have 100, 300, 800, 2300, 9900. Although we did not really change, the content on the array A, we actually made the change on ARR, because what happened now, ARR is not going to be really like equal the array. It's going to be a reference pointing exactly to where A is pointing. So ARR is just going to be replacing B. And then we made the changes on ARR. So even now when we try to access the elements, we pretty much have access to them, but it's going to be with the new values. Okay, so that's why we were able to see the values pretty much that were modified. If I try to actually, display these values before I made the call to the method, and then let me do s out with a separator, over here you will see the old values, and then after the separator, because that's when we made the call, you will be able to see the new values. Okay, so even now if you made a change down here, obviously over here you only have access to A, obviously, but you know what I mean is, even if you make now change ARR of A, and then let's just have kind of like the print in here, and let's actually call this one more time and see what we get. So you're going to be able to see the values change dramatically over here, because this will change the value multiplied by 100. This will also multiply the new values by 100, and this will also multiply, the last values by also 100. So that explains what you would see over here. Okay, so this is an important thing, and it relates to the homework that I'm actually working on right now. So I just thought it might be helpful. Okay, thank you guys, and see you soon. Bye bye.